Hello everyone, welcome back to my Chem Corner. In today's video, we're going to do question number 4.16 that says write the significance or applications of dipole moment. So before we move into its applications, we need to know what is a dipole movement. I have explained about how dipole moment is relative to the geometry of a molecule in the previous video. And in this video, we're going to talk about the applications or significance of a dipole moment. So, as I always say, before you move into the actual and understanding the actual question, try to learn about the basic of what is asked in the question. So, what is a dipole moment? All right. So, as it clearly says, in a heteronuclear molecule meaning the atoms that are present will have a difference in electronegativity. If you have the atoms in a molecule with same electronegativity, then it is called as a homonuclear. But hetero meaning different electronegativities in a molecule. Now, when you have different electronegativities as told, what happens? What is happening in the molecule? There is polarization. All right, because when you have a heteronuclear molecule, there is difference in electronegativity. The electrons are going to be moving to only one particular atom, and therefore they will have two different poles, a partial positive pole and a partial negative pole. So because of that, polarization takes place. So here it says, as a result, one end of the molecule acquires a partial positive charge while the other becomes negative, and hence a molecule is said to possess a dipole. Okay, so please remember that when you have heteronuclear molecule only, you will have polarization taking place because the electrons are going to be pulled towards the more electronegative element, creating a positive charge and a negative charge. Now, the product of magnitude of the charge and the distance between the center of the positive negative charges is called a dipole moment. I've told this also in the previous video that when we talk magnitude of the charge, you are talking about the direction in which the charge is going to move and its distance from the centers of those charges. That is called as a dipole moment. Now, vector, it is a vector quantity. Why? Because you can talk about the magnitude or the direction of the charge. Therefore, it is called as a vector quantity. And it is represented by an arrow with its tail at the positive center. For example, if I am taking HCl as an example, chlorine atom has more electronegativity when compared to hydrogen atom. So you have one electron from hydrogen and one electron from chlorine. Now, if you want to show the dipole character in this, how are you going to show? Because chlorine is more electronegative, it will pull electrons towards itself. So I'm going to draw an arrow facing towards the more electronegative element. So here it is represented by an arrow with its tail at the positive center. You have the tail at the positive center, which is hydrogen, and the head pointing towards the negative center. The head of the arrow is facing towards the negative center. Now this is how a dipole movement is represented. All right, always the arrow is moving in the direction of the more electronegative element. Now, dipole moment is used to differentiate between a polar and a non-polar bond, since all known polar molecules have zero dipole moment. So here you can see this is having one direction, right? It moves in one direction, and therefore you will see that this molecule will have a particular dipole moment. It is creating a partial negative center and a partial positive center. Therefore, this is polar. Now, if I'm looking at a molecule like CO2, you have two oxygen whose electronegativity is the same. So what happens? This carbon is going to pull the electrons towards itself. Sorry, this oxygen is going to pull electron towards itself, and this oxygen is also going to pull electron towards itself. Now, when this happens, one dipole cancels out the other dipole, and therefore here it is zero. And when it is zero, these molecules are called as a non-polar molecule. Alright, so when one dipole cancels the other, or rather when the arrow goes away from the central atom, then such molecules are going to be non-polar because one dipole is going to cancel the other. Alright, here when it moves in one direction, the more electronegative element is going to get a negative charge, and the less electronegative element is going to get a partial positive charge, creating a dipole moment. So polar molecules will have a particular value for the dipole moment, whereas non-polar molecules will have a dipole moment of 0. Now coming to its significance. Where are we going to use it, and what is the purpose of it? What is the application? Now, when you look at dipole moment, it is used to differentiate between polar and non-polar bonds, since all non-polar molecules have zero dipole moments. That's exactly what we just saw right now. It is used to signify the polar and a non-polar molecule. It also helps to calculate the percentage of ionic character in a molecule. As per Fajans rule, we always say that a covalent molecule will also have a slightly ionic character in it. So here we will also be able to tell the percentage of ionic character in a molecule. Alright, so just to sum it up, when you have a dipole moment, a value for a dipole moment, then such molecules are classified under polar molecules, whereas the ones that have zero dipole moment are coming under a non-polar molecule.